chi-square test of association independence. So this is the example here. You can look through and see the details of, for example, that we have a random sample of 8,474 people. And we are checking their relationship between the heart disease and their rating on the Anger scale test. Again, the reason we know this is a chi-square test of association and independence is because we are not taking having a bunch of different treatments and comparing them. We are not splitting this. We are not splitting the sample into different groups. We are not taking separate, like 3 separate samples of people. We're taking one sample from the same category and just looking at 2 different traits about them and seeing if they're related to each other. That's chi-square test of association. So, they'll go through and find the expected counts, but we'll do this on the calculator. Again, the way that I would encourage you to look at this is to give the null hypothesis being that there's no association between the 2 variables, and the alternative is that there is an association between the 2 variables. Formula is the same. Degrees of freedom is calculated the same way. The conditions are the same. We're checking the expected counts being at least 5 instead of the normal condition. Don't call it normal when it's not normal. Chi-square distribution is not a normal distribution. All right, let's do it. This is what you should get for expected counts in the calculator when you do it. But let's actually look at how this 4-step process is going to look. First off, the null hypothesis is that there is no association between the 2 variables. So there's no association between anger level and heart disease in this population. The alternative is that there is an association between anger level and heart disease. And we're going to use a 0.05 alpha level. So null hypothesis, there's no association between the variables. Alternative is that there is an association between the 2 variables. Pausing for about 10 more seconds, then moving on. Step 2. This is called a chi-square test of association or a chi-square test of independence. Random, we had a random sample. Expected counts were at least 5. Yes, and they put the table on the last slide of the expected counts. So they're not putting that there. And then independent is 10 times population mean, 10 times sample size. We begin by calculating the test statistic. So in your calculators, follow along, make sure you can get this out. So there's my matrix. So I'm going to go out, go stat over to tests. This is chi-square test. Observed in matrix A, expected I want to be put in matrix B. And we're going to go calculate. There's the p-value. Remember, that is times 10 to the negative 4th. So that means it's 0.000323. There's chi-square statistic. Degrees of freedom is 2. That's number of rows minus 1 times number of columns minus 1. Make sure you put that in your step 3. And then if I go over to matrix B, I can go down and see, oh, there's my expected counts. I would say show how you're getting degrees of freedom. So usually it's like n minus 1, or in goodness of fit, it's number of categories minus 1. Here, you should put 2 minus 1 times 3 minus 1 equals 2. First two terms, put a dot, 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 and then the last term equals 16.077. So that means there's the p-value. It's saying if you're using the table, here's how to do it. If you're using the calculator, here's how to do it. That's all that that's doing. And finally, p-value is clearly less than our alpha level. They're putting the clearly in there. Less than alpha. We're going to reject the null hypothesis, conclude that there is an association between the anger level and heart disease. Pausing for about 10 seconds to make sure you can get those details down. And see if there are any questions on that problem. All right. Let me recap all of the different tests that we have here. Actually, the calculator can do that for me. So if I go to stat tests, reason I'm saying this is because one of the things I'm going to ask on the test coming up is I'm going to ask you to be able to say, read a situation and then tell me what kind of hypothesis test to make. Is it a two proportion z-test? Is it a one sample t-test? Is it a chi-square test of association? Is it a chi-square test of goodness of fit? So I want to just run down these and make sure you know what each are. Z-test we don't really use. T-test is a one sample t-test. And remember, when I say that, my null and alternative are going to be about means. I have two sample t-tests if I'm comparing the difference between two different means. Usually that means my null hypothesis is that the mean difference is 0. Alternative is that the mean difference is not 0. Then I have one proportion z-test and two proportion z-test. So we just got one proportion. It's one proportion. If we have two proportions that we're comparing the difference between them, then that's two proportion z-test. Then we also have the same things for the confidence intervals. So we have one sample and two sample for proportions and means with the confidence intervals. And then we have a chi-square goodness of fit test. Remember, that's when we just have one variable, one set of categories that we're looking at the distribution of. And then we have our chi-square test for homogeneity and chi-square test of association. And we've been talking today and yesterday about the difference between those. So you should be able to read a situation and look at the question being asked and know what kind of test we are going to be performing. By the way, we'll look at this one, the linear regression one, in Chapter 12. We'll be talking about that one very briefly, just to give you a heads up and looking ahead. I'm going to be giving it a similar way I did Chapter 10. So I'm going to be giving a little piece of it in class on Tuesday. And then the rest of the test will be open on Canvas for you to take. So that's what that's how the test is going to look.